Welcome! Imagine voyaging through space, not with roaring rockets, but by harnessing the very light of the sun. This is the concept behind solar sails, a truly revolutionary approach to spacecraft propulsion. Instead of needing tons of heavy propellant, solar sails use the constant pressure from sunlight itself. Photons, the particles of light, carry momentum. Even though they have no mass, when they bounce off a large, reflective sail, they give it a tiny push. This push, called solar radiation pressure, is incredibly small. Think of it like the gentlest breeze. But in the frictionless vacuum of space, this constant push, day after day, can accelerate a spacecraft to very high speeds over time, potentially faster than conventional rockets for long journeys. The closer to the sun, the stronger the push. Further away, it weakens. Steering is achieved much like a sailboat tacking in the wind, by carefully angling the sail relative to the sun to direct the thrust. Of course, building and flying these giant thin sails presents unique engineering hurdles. The sails need to be enormous, covering hundreds or even thousands of square meters, yet incredibly thin and lightweight. Materials like aluminized mylar have been used, but research continues into stronger, lighter options. Folding these vast sails for launch and then reliably unfolding them in space is another major challenge. Many designs use long, lightweight booms to stretch the sail taut, like spars on a sailboat. Japan's IKAROS mission successfully tested deploying a sail by spinning the spacecraft, using centrifugal force. Maintaining the sail's exact shape and controlling its orientation precisely are also critical for navigation. Despite the challenges, we've seen exciting progress. Early missions like IKAROS in 2010 and the Planetary Society's LightSail 2, which flew from 2019 to 2022, proved the basic principles work. More recently, NASA's Advanced Composite Solar Sail System, or ACS-3, launched in April 2024 and successfully deployed its 80-square-meter sail in August 2024. ACS-3 is testing new lightweight composite booms, which are much lighter and resist warping from temperature changes far better than older metal booms. This mission is paving the way for much larger sails, perhaps up to 2,000 square meters. Other innovative ideas are also being explored, like sails deployed through spinning, or even diffractive sails that use optical gratings instead of simple reflection. There are even concepts for extreme solar sailing, diving very close to the sun to get a massive acceleration boost for rapid trips to the outer solar system, or even interstellar space. So, what could we do with solar sails? Potential applications are numerous. Maintaining satellites in specific locations like Lagrange points for space weather monitoring, exploring near-Earth asteroids, providing low-cost transport within the inner solar system, achieving unique orbits like flying over the sun's poles, and powering high-speed missions to the outer planets. Some concepts even envision using powerful ground-based lasers to push sails towards other stars. Naturally, challenges remain. The thrust is low, meaning acceleration is slow, especially far from the sun. The sails are delicate and must operate high above Earth's atmosphere to avoid drag. But the core promise of propellant-less travel, fueled only by sunlight, is immense. Solar sails offer potentially unlimited change in velocity, making ambitious, long-duration missions more feasible and affordable. They truly could usher in a new era of exploring our solar system, and maybe, one day, the stars beyond. Thanks for tuning in.